Okay, our chapter 5 is about what? About beam bending. Right. So we had 3 chapters talking about beam. Chapter 5 is beam bending, and then beam deflection and shears in beam, right? So this is chapter 5 is the first chapter about beam that is talking about beam bending. It's basically the stress, the bending stress, right? So the first part, which is super important, is to determine the section properties, right? That is the I, right? The I and local centroid and the overall centroid, right? So we need to determine the I value, sometimes Ix, sometimes Iy. So you should be familiar, with those concepts, right? So thinking about here, so if we have a cross section, a rectangular cross section, then you have B here, and you have H here, and this is our x-axis and the y-axis. Okay, so what is Ix? What is Ix? It's the moment of inertia about x-axis. What is Ix? Ix should be what? B h cubed over 12. Right? Then how about Iy? Moment of inertia with respect to y-axis. How to calculate this? It should be hb cubed over 12. Right? And this is just a simple cross sections. And we also need to know how to determine the section properties of composite section, right? If you have a composite section like this, right? This is a composite section, T-shaped or a I-shaped beam, right? So if you have this cross section, then the I will be calculated as this is the equation, okay? IC plus D square A. Right? And the centroid Y bar will be calculated by sum of YI AI over sum of AI. Right? So you can use the 2 tables, use our table method, right? There's at least 2 tables, and to cut the composite area to different sections, to different sub areas, then to find out, to solve the I and Y bar. So this is the basic things in this chapter. Right? You need to determine correctly the section properties so that you can do further calculations. Okay, so based on that, so we can calculate the bending stress. The bending stress. What is the nature of bending stress? Is that normal stress or shear stress? Okay, you should be able to answer this question, right? Is that normal stress or shear stress? Okay, here's the answer, right? The bending stress, the basic equation said sigma, is this normal or shear? Okay, sigma equals m times y over I. Okay, the m is the bending moment, and y is the distance of the point of concern from the neutral axis. Right? So I is the moment of inertia. And we have another equation that is the sigma max, right, equals mc over I. Right? So this c is just the maximum distance from the point of concern to the neutral axis. So for a simple cross section, not for simple, for all cross sections, those will be, the c will be from the surface, right, from the top or bottom surface to the centroid of the cross section. Right. So these equations, these methods are valid for both simple cross sections like this, like this, or composite sections. Right? Even you have composite sections like this is also valid. You just need to determine the centroid, right? The centroid. Then for a point of concern, let's see here, right? So you just need to determine the y value in this way, right? So this is a y value to be used here in this equation, right? For the calculation. Okay, then in the third part, we also talked about composite beams. Composite beams composed of different materials, right? Composite beams, and we need to do what? Transform sections. Since if you have two different materials, it's hard to do calculation. Right? We need to transform the different materials into uniform materials. Right? So the basic equation to do the transformation will be N equals E2 over E1. Right? So we call this one phase 1 the basic material. Right? The base material. Base material means that your material 2 will be transformed into material 1. Right? And this one is to be transformed. To be transformed material is the material 2. So your material 2 will be transformed into material 1, right? So let's see here. If you have a composite cross section that's shown here, and this is a steel, here is your wood, right? Then if you select wood as material 1 as the base material and the steel as material 2, right? Then it will become this. Right? This is into wood. Wood is material 1. But if you want to use steel as material 1, then you can transform it into this shape. Why both steel? In this case, steel is E1, right? Well, knowing this, based on this first equation, after the transformation, right? After the transformation, you get a composite shape. Right? The shape, the T shape, basically it will become a T shape, right? So you need to determine, based on this, you will get a T shape. Then determine what Y bar and I. Then you will use this equation to find out the bending stress using this equation, or my over I, depending on the points. If the point is on the top or bottom, you will just use MC over I. If it's a random point between the centroid and the surface, it will be just a my over I, right? Then you will be able to you will need to do another transformation. Since you changed the properties of the materials, steel into wood or wood into steel, you need to transform the calculated result back. Right? For the base material, you do not need to change anything. The calculated stress will be the stress. But for the being transformed material, the E2, right, the material 2, you need to do one more transformation. Right? That is the stress in material 2. Right? Will need to be transformed by n times the calculated stress in phase 2. Right? So here is a question for you. If you transformed the steel into wood and getting a larger section, right? And the calculation set your stress, the bending stress in a point here is 10 MPa. Right? So what is the real bending stress at this point? The 10 is calculated result, right? Since you transform the steel into wood, then you get this result. So what is the real stress in the steel? Right? Based on the equation, you will see that N times sigma 2 prime. Well, is this N larger than 1 or smaller than 1 in this case? So will this sigma 2 larger than 10 or smaller than 10? Okay, this is the equation you need to figure out by yourself. Okay, go back to review the examples and figure out this. This is important. Okay, this is very important. Just go back to check and make sure you understand this, and you can answer this correctly. Then the fourth part of this chapter will be combined loading. Right, combined loading. And in chapter 5, we just gave simple combinations, and that is M plus P, right? So we have learned more in chapter 10, so I will not review this here. I just combine this section in chapter 5 and chapter 10 together and review them together. Okay?